Dear colleagues, let's continue. Now we have a second part of our session 1, Intelligent Information Technologies, and this part of second week. Welcome, please.
Dear ladies and gentlemen, we are glad to welcome you at the second part of Intelligent Information Technology section. And today, according to our agenda, we have 5 presentations. Not 5, 6, I'm sorry. Let me tell you about the presentation timing. We have 10 minutes for the presentation and 5 minutes for questions and answers section. So it means 15 minutes for one speaker. Let me announce the first... 7 presentations. I'm sorry, maybe I looked at the wrong section. The first presentation is by Vitaly Pavlyshin, Eduard Mondyuk, Alexander Barmak, Yuri Krak, Robertas Demosavius. The name of the speech is Modeling Environment Intelligent Transport System for Eco-Friendly Urban Mobility. Is the presenter here?
Yes.
Please, could you share your screen? The floor is yours.
Sure. Okay. Hello, my name is Vitaly Pavlyshin. I receive a PhD study in Khmelnytsky National University. The subject of my presentation today, as was mentioned, is intelligent transport system environment modeling for eco-friendly urban mobility. We will, in border of these experiments, we will try to create a model of vehicle movement of my home city of Khmelnytsky, and we'll attempt to make it more eco-friendly. There is obviously no need to explain why a city transportation system is important for human everyday life. One can surely state that it is vital for any city, and no city can live without it. This includes people transport, good transportation, and obviously every city and town in the world has it. And we all know the side effects that come with any transportation system. Those are traffic jams, unexpected delays caused by, and the very painful problem since recently, this is air pollution. This study introduces a modeling environment of a city transportation system using Khmelnytsky as a city prototype. Active agents were used for this modeling, and performance improvements were received when traffic lights durations are adjusted. Here we started with creating the city map and its transportation routes. And the end result looks like, as you can see on this slide. This is not the whole city, as you can see, but its central area. This is the most loaded part of road traffic, and with all the most popular transportation routes included. Model itself has roads themselves, crossroads, number of lines, and movement rules, how each driver is supposed to pass the crossroad, which line they can choose when they go to which direction. Next, what we did is we defined so-called areas of interest for transportation. Again, we use a typical Khmelnytsky working day, morning time. And during this time, people from living quarters of the city are interested to move to the business quarters of the city. On these slides, you can see we have living quarters defined and marked them in green. And this is the source of our traffic, the source of transportation. And there are purple regions. These are business regions and destination of our traffic. It was also taken into account, it was also considered that in addition to directed traffic to desired traffic, each city has, during its normal working day, has random journeys that may start and end in any random point in the city. So these were pre-created. This slide demonstrates all the areas, and we named them to the corresponding regions inside the city of Khmelnytsky. Next, what we did is we defined key traffic lights that, as we judge, impact the most the transportation time and, as a result, air pollution. On this map, you can see them marked in red cycles. Also, the slide shows our region of interest, mentioned in previously. This is how we run the simulation. This is how we run the simulation. Each region of interest had a percentage of interest assigned, a percentage of traffic as a result assigned to it. And these are drivers that would like to move from the original initial region, green region, to the destination region, purple region. On top of that, as was mentioned, percentage of random traffic was added. These are vehicles that move from any random point of the city to some different random point. I want to note that each simulation run was identical. This means all vehicles, including those that exist for random routes, appears exactly at the same moment of simulation time, at the same offset of simulation run. As a result, difference between each simulation output is controlled only by active agents, traffic lights. All other factors are identical from one run to another. At the end of each run output, values are collected to compare with results of other run. And the objective function here is carbon dioxide emission. Results show that we can receive improvements when we run this approach. The table on these slides show different traffic light green light duration for each significant crossroad that we selected and defined earlier. This table doesn't show all the sets. We use it for the experiments. It shows only the first two, and this was done for the sake of space. The way we run the experiment is we took set one, first set, and then all other sets performance was compared to it as to the initial set. These are simulation results. They are in few numbers. Table shows all the routes from one desired area to another desired area. And for each set of traffic lights offset, it shows total sum of carbon dioxide emission in milligrams. Also, difference in percentage is included here as well. Here we see negative values. Negative values, in fact, means positive impact, as the emission was reduced. It was less than initial. This slide shows simulation result as a chart. As you can see, same main transportation routes are included. They are present at the bottom, and each bar represents the total number of carbon dioxide that was measured during the run. While it's clearly visible that, depending on simulation set, each particular route performs differently. Some produce good results, some produce good results, some produce worse results. But in average, it's clearly visible that improvements are present. In conclusion, I would like to say that experiment clearly shows that with this approach, improvement is possible, and it's definitely that traffic lights adjustment impact the carbon dioxide emission, and that using different offset values, carbon dioxide was decreased significantly from 2.5 to 7%. However, this is not the end. There is still a lot of work to do. We can introduce more active agents, consider line configuration rules and passing and reverse line movement. We can define speed limits. We can think of various unpredictable situations that impacts the traffic, like traffic accidents, etc. However, the modeling we use it allows us to consider all these factors, and we are positive we can proceed with this study and achieve more results. Thank you for your attention. This is all I have. Ready for your questions.
Thank you so much, Vitaly, for your presentation, dear colleagues. Here in Khmelnytsky, currently we have an air alarm, but we asked everyone to be in shelters, not to interrupt our conference. So please, colleagues, keep safe, and we continue. If someone has questions to Vitaly, please, you're welcome.
Some question. What optimization methods do you plan to use?
Various are being considered. The most how would you put this? The most hopes are given to, I think, reinforcement learning, where we can pretty much have an observer that would validate the next possible set of actions that our agents can produce and receive results. There are concerns here, quite numerous. As you can see, we run the whole experiment even not on the whole Khmelnytsky, but part of it. And there are cities that are larger than Khmelnytsky, so performance could be an issue, and as a result, we will need to think maybe of some different ways how to run the simulation. Maybe not run each driver, each vehicle in particular, but operate them with as sets of values. Use some maybe traffic pressure, car pressure. It's still to be determined, but overall, that is the direction we are going to use.
Thank you.
Thank you so much, Vitaly. Any other questions, dear colleagues? If there are no questions, please, I have one more question. Dear Vitaly, could you please tell me which methods of modeling did you use in this presentation, and what drawbacks can you indicate for these models? What
You mean
drawbacks can you see?
You mean what tools did we use to run
What
this?
tools? Yes.
Primary, it was this German developed tool called Sumo. It was used to drive the simulation itself. Then a whole number of tools was used to prepare the data. Obviously, we need to create a map and load all the crossroads. This was not done manually. We used open map to convert all the transportation system of Khmelnytsky in a way that Sumo can run it. Then we created some scripts to, first of all, we defined regions. We created some scripts to populate traffic, both desired traffic and this random traffic. You simply use a set of Python-driven scripts for all this. At the end, there was a huge number of XMLs that is pretty much fed to Sumo. Sumo performs the run, outputs the result. Obviously, we also need to define the actual vehicles, how they run, what level or carbon dioxide they produce. And this is how whole thing was created.
Thank you so much for your question. And if there are no more questions, we go to the next presentation. That is by Alexander Rozhansky, Eduard Monzuk, Alexander Bormak, Yuri Krak, and Neboja Bakanin, an approach to optimizing CO2 emissions in traffic control via reinforcement learning. Is the presenter here? The microphone, please. Alexander, your microphone is
Excuse me. Yeah. Good afternoon, attendees. Can you see my screen and the
Not
presentation?
yet. Not yet.
Okay, one moment. What about now?
Now we can. Everything's all right. Thank you.
Okay. Hello, my name is Alexander Rozhansky. I am receiving PhD in Khmelnytsky National University, and the subject of my presentation is an approach to optimize CO2 emissions in traffic control and via the reinforcement learning. Obviously, we cannot overemphasize the importance of traffic management and its optimization for city life. The economy of a city heavily depends on the transport network. Ecology of the city depends on it heavily too. In this study, our goal is to optimize city traffic using reinforcement learning technique based on real-time observed traffic. We will use neural network for this, and we will see what results we are going to receive using this method. So first of all, we will start with the selection of a right simulation map. After reviewing a lot of different publications and studying the situation, we figured out that whole world is using set of well-known and calibrated scenarios. Scenarios are basically divided on synthetic scenarios and real-world scenarios. The most famous synthetic scenarios are arterial 4 x4 and grid 4 x4. Most famous and frequently used real-world scenarios are Cologne. There are like 3 different scenarios in Cologne city, and Ingolstadt, which also has 3 different scenario in this city. All those scenarios were done by cameras which were measuring information on streets, and this was carefully gathered, and it's currently all this information is public on GitHub, and people can use this information for their own studies. This like validated and proven by all scientific society that this is good scenarios for any test of this type. In our today's work, we decided to use a grid 4x4 scenario, which is basically what you see on the screen. It was used in many studies, and most recently is in study by Mr. Chen at 2020. We have it in references, so do not read long name of the study, but this is how this grid works. And this is how it works if you zoom in into each specific crossroad intersection. As you can see, it's 3 lines and basically 8 directions. And this is how this looks in Sumo. And Sumo is basically what we use to run our simulations on behind of the neural network and reinforcement learning. Sumo is basically our simulation engine which runs the simulation. It uses again the configuration files of this synthetic scenarios, which are validated by a lot of people to be very accurate. And we expect that we can receive the results which are very close to the real life and close to the results which are receiving in other studies, which we will compare our results with. Now we will go more close to the method itself. In our experiment, we would call our method MP-Light CO2. The reason our main goal in this method is to concentrate on CO2 emission reduction. But we will also see how it will work with optimization on traffic and overall. Let's review method quickly in details. First of all, we are going to use a shared agent for all intersections. I will not be very specific about how reinforcement learning works, but in overall, we have agent. And agent is basically a map, an algorithm which runs the simulation. And learning, in this case, it's using neural network on the behind, and deep Q learning method. This is well-known algorithm of reinforcement learning. It's one of the reinforcement learning kind of package. So once you get into the reinforcement learning, you can choose which algorithm you want to use to perform your experiment. We use deep learning because we think that the best approach is to use neural networks for learning, not the different methods. So that was the reason why we decided to go this way. Second important topic here is we are going to use pressure concept. It was first introduced by Varaya presentation in 2013. And it's basically was proven there that it's better to optimize not the traffic itself, but optimize the concept of pressure, where pressure is basically a difference between number of queuing vehicles in incoming lane and outgoing lanes. And by optimizing this pressure value in city overall through the whole city gives us the best results in terms of how the city traffic behaves. Next important part is action space. So learning agent, basically in reinforcement learning, we use concept of action space, which are basically all actions are possible for agent to take. And in our specific case, those are possible actions which on each direction, which vehicle can take. Deep Q learning specifically works very good with fixed action spaces. In our case, it works perfectly because our action space is just 8 possible options of movements. And the next very important part of this is reward function. Reward function is kind of bread and butter of reinforcement learning method because it decides how neural network will learn. In our case, we use concept of pressure. So our reward function would be the difference between outgoing and incoming lanes emissions of CO2 between incoming and outgoing lanes, all lanes of the intersection. And obviously for each intersection, it will be different in values, but the function itself stays the same. So by using this reward function, we expect the reinforcement learning to maximize it, and by doing that, we're going to get better traffic management. So we run together with our experiment. We also used other experiments which other people and were doing on different studies, and we will compare it with this. Well, it's 4 methods in overall, 3 methods, 1 method which we did, and 3 other methods. One of those is max pressure control method by Varaya 2013. Another is MP Light method by CCN 2020. And the last one is IDQN method. It's another method which is also using neural network. It's using independent agents. It means that they're going to use separate neural network for each intersection, while we are using the same neural network for all intersections. And the reason for that is we want to see, and we want our network to know all possible configurations of intersections and learn how to act on it. While in this method, they decided that each intersection will receive their own neural network. This method was created by Out at 2020. This paper is also included in our references. So again, and the last one is our own method, which is kind of was briefly described above. One moment. Okay, so basically on this slide, we see results of those 4 methods performing. On the x-axis of those charts, we see basically time, but it's also like simulations run during the learning. So basically 1 to 100 means that we learned that each of those methods were doing 100 of simulations for all those methods basically, but the first method does not use neural network. It uses another approach, describe it in their paper, but those 3 methods, MP Light, CO2, and in the IDQN are using neural networks, so they are learning. It means each following simulation run is using what neural network learned. And we don't do more than 100, but basically we get a plateau. After 100, it's basically gives us the best results. After this, it does not get better. What we see on those and the metric displayed on this is basically CO2 emission. And obviously it's not perfectly seen on these charts, but we see that MP Light CO2 behaves better than MP Light, behaves better than max pressure, and quite close to the QN method, which is alternative to the
Dear Alexander, sorry to interrupt you, but we need to fit in timing, so please speed up with your presentation.
I will speed up. We're getting.
Thank you.
So this table gives us a comparison of the results. It's basically just a table of what we see above, but we have little more different attributes displayed here. We have waiting time, duration, CO2 emission, and Q length. On all those things, we see that MP Light CO2 behaves better than all methods, but IDQN is also giving us a good results. It's dependent on map and on different tests and dependence on the length of simulation, as we already know. And so those methods are basically very close. The conclusion is of the study is we proposed deep reinforcement learning method, which solves the problem on city traffic on the big on the big models. It can work with any number of intersections. It can do it on quite complex models. It's based on other methods which were introduced in the past by different people, which are MP Light, Press Light, FRAP methods. But our method was tweaked to prioritize CO2 metric as a key component, while other methods were targeting mostly city traffic, waiting time, and other parameters. We see that by prioritizing CO2, we are getting sometimes better results than other methods which have city traffic waiting time as a priority. We used Sumo to do this presentation, well-established grid for model. We know that our solution, and we see by results that our solution is at least not worse than other and frequently better. And in general, all methods give us results which improve waiting time up to 33% reduction of queue lengths on intersections by 75-76%, and reduction in CO2 emissions by 32-33%, just by running basically in average any of those methods. But our methods is one of the best. That's what we see. Thank you, attendees, for listening, and thank you. I'm looking forward for answering questions.
Thank you so much for your presentation. Dear colleagues, any questions, please?
What neural network are you using?
The neural network it was used from the study FRAP, which is referenced here. It's quite complex neural network. It does not capture traffic. Instead, it captures graphical matrices which are generated based on configuration of each intersection and current state of the traffic on the intersection. So those guys came up with the idea that they generate a matrix, and then this matrix is going to the network, and network uses convolution layers. It's quite a complex network. I did not present it here mostly because it was created in FRAP study, and I used this study as a source of this neural network. That's it.
Thank you.
Dear colleagues, more questions, please? If there are no more questions, we give a word to our next speaker, Lyudmila Gryzun and Oleksiy Lutovchenko. The name of the presentation is Predicting COVID-19 Incidents Based on Machine Learning. Are the speakers presented, please?
Yes, we are here. Hope that everything is okay. Just a moment, I'm widening my presentation. Dear colleagues, I'm really happy to see everybody here, to greet all the participants of the 5th International Workshop. And just a moment, I'm playing my presentation on the full screen. Sorry. Okay, we are. Dear colleagues, my name is Lyudmila Gryzun. I'm professor Information Systems Department of Simon Kuznets Kharkiv National University of Economics, Kharkiv City, Ukraine, and I'm glad to introduce also my co-author, Oleksiy Lutovchenko, master student of Information Systems Department. So the topic of our research today is predicting COVID-19 incidences based on machine learning. Here you can see the outline of our presentation. And in terms of the urgency of the research, since the emergence of the COVID-19 virus, humanity has faced a lot of which are still relevant today. The number of people infected with COVID tends to rise and fall despite the advent of vaccine, as the virus is constantly mutating. The vaccination is considered to be an effective prevention strategy. However, long-term investigations are necessary to estimate clinical effects and side effects of this vaccination on different group of patients. According to different studies on pandemic prediction, there is a high probability that pandemic will remain a common disease or become endemic in future. It means mankind has to learn how to coexist with it and go on living and working effectively in terms when the pandemic has had significant negative impacts on economics, slowing down the production of vital goods, and etc. The said evidence encourages the use of mathematical methods to analyze the pandemic evolution and to plan relevant response strategies accordingly. Under these conditions, the global community adapted to the changes and getting more digital needs for relevant software tools which could assist healthcare structures, facilitate the social and business processes through predicting threats and calculating risk caused by the pandemic. So the goal of our work is to develop the web application for predicting COVID-19 based on machine learning and to present the paper, the progress and the results of this work. In order to achieve these goals, we had to undertake some core steps. So they were analyzed recent studies as well as existing applications realizing similar functions of subject domain so as to determine their shortcomings and limitations. They were also provided our investigation on purpose of the selection of the proper machine learning model for prediction as for their accuracy in terms of various metrics. And finally, the said investigation made the mathematical basis for the development of the author's web application on COVID-19's prediction build, which was actually done. So according to studies, machine learning approach, being a powerful tool for forecasting, faces serious difficulties connected with detecting the model which is suitable to the existing data. In the progress of our work, they were analyzed the papers presenting different methods to identify the models for describing evolution of the COVID-19 pandemic. In particular, they were analyzed compared of exponential smoothing techniques, Riemann model and Poisson counting models to choose the best model for data from exact country. They were also analyzed some research focusing on the 4 nonlinear models and came to the conclusion that Comper's model is the most suitable here. However, they were also revealed some limitations. In addition, they were analyzed the set of papers presented the approaches built around comparamental models, which also revealed the core problem for the using of an epidemic outspread modeling. In the context of our research, also it was really important to analyze the resources describing the functionality of analogous. And so here you can see the summary of this analysis. We analyzed the functionality of 3 core applications: IHME, European COVID-19 Forecast Hub, and Altimeter. So, summarizing our analysis of related research, we could conclude that despite the diversity of research on the making predictions of pandemic evolution and their practical implementations, there are quite serious limitations which reveal challenges of forecasting COVID-19 incidences based on machine learning models. Among them, it's important to point out the predictions based mostly on limited data sets. It's not global forecasting, but only for single country or a region, not revealed confidence interval for forecasting, limited modes of information visualization and data downloading, absence of holistic approach to detect most suitable model for reliable and long-term forecasts, etc. These limitations highlight challenges of forecasting COVID-19 incidences based on machine learning models, confirm the urgency of the research in this field, and made the theoretical background of our work. So based on the findings presented above, it was provided the investigation on purpose of the selection of the most appropriate machine learning model, which can become a mathematical basis for our application. They were chosen some models to compare their effectiveness and accuracy by methods of finding and error. So in particular, they were selected linear regression as a simple and efficient algorithm for modeling and predicting numerical data. The Gompertz growth algorithm is a mathematical model that is used to describe the growth population, biological systems, and others. And Holt-Winters method, also known as a triple exponential smoothing, as a popular time series focusing method. In order to assess the said model's accuracy, they will consider different approaches: mean absolute percentage error, mean absolute error, root mean squared error, which was approved as a leading one to estimate the said model's accuracy. Although to understand the whole picture, other metrics were also used in order to assess the accuracy of the selected models. Here you can see the results of our estimations. For calculation, they were taken two data sets with period of 2 months, where there is a small difference from day to day in the first data set and enormous differences in the second data set. And the results for linear regression for the second data set are insufficient. Yeah, and we also tested Gompertz model and prediction with the help of Gompertz model function for the first data set presented here, and it looks quite acceptable according to all of the metrics. However, for the second data set with high fluctuation in data, they were revealed drawbacks and quite enormous indicators of all of the metrics. So it was clear that it's necessary to apply a different model, which was also tested by us. Here you can see the prediction of cases by exponential smoothing model on the second data set with high fluctuations of data, and the results according to all of the metrics showed that demonstrated the quite acceptable results. So here you can see the summary of comparisons of models by all of the metrics, and it can be concluded that the Holt-Winters method is a better choice than Gompertz growth and linear regression models for building predictions with the seasonal factors. Our practical conclusions were also supported by theoretical facts. Firstly, the Holt-Winters method is designed to handle both trend and seasonality, which are common in epidemiological data like COVID-19 case counts, whereas other models do not take seasonality into account. Secondly, unlike simple linear regression, which assumes a constant rate of change, or the Gompertz function, which assumes a specific growth form, the Holt-Winters method can be adapted to changes over time, providing more accurate short-term forecasts. In addition, the Holt-Winters method is more robust to outliers than simple linear regression method, which is really crucial for exactly COVID-19 data, which can have sudden leaps due to the changes in reporting practices. Therefore, the Holt-Winters model was selected as the most appropriate model for the task of COVID-19 incidences focusing and implemented as a mathematical basis for the implementation of author's web application, which was done. As a result of the whole analysis and design and mathematical model, the web application was developed using the stack of technologies, which you can see on the screen. In terms of the functionality of our web application, the developed web application provides the visualization of COVID-19 incidences, including predictions of new cases and deaths for different nations, continents, and the world overall. Moreover, the application suggests confidence interval, which indicates the error of the model for a specific data set. The application visualizes data in different representations, and charts provide this visualization in various modes. Cases of infection basis, new cases, total cases, daily, weekly, etc., both in linear and in different forms of charts. In addition, the application also provides viewing statistics in the form table. Furthermore, it has additional function as searching, sorting by different columns, and comparing data across different dates, offering a significant advantage to users. It is also possible to download data of any nation or region separately in CSV or JSON files. In terms of conclusions, in the progress of work based on the relevant theoretical framework, they will achieve the goal as for development of a web application for predictive of COVID-19's incidents based on machine learning. Some selected machine learning for prediction were analyzed and estimated the accuracy in terms of various methods. So based on these estimations, there was proposed the Holt-Winters as the most appropriate model for the task of COVID-19 incidents forecasting. The said model was implemented as a mathematical basis for development of author's web application. Thanks due to the analysis of the application functionality, it can be concluded that they will overcome some limitations of the similar applications revealed in the theoretical part of the paper. In particular, in the application, it is realized global forecasting as well as forecasting as for country region. Confidence interval for forecasting is suggested with indication of error of the model for a specific data set. The modes of information visualization and representations were significantly widened in comparison with the analogous, and data loading is improved in terms of forming separate files for different formats. Also, the prospects of our research were outlined in the lines of automatizing the choice of better machine learning model, which would be really beneficial, adding the facility for the users to compare the models. That is all, dear colleagues. Thank you for your attention, and we are ready to answer your questions. Me and my co-author, Alexey Litovchenko, who is also here. You're welcome.
Thank you so much for your presentation, dear colleagues. Do you have questions?
There's some question. Are you planning to use a neural network for prediction?
Maybe, yeah.
Yeah, Alexey Litovchenko is going to answer, please.
Yes, thank you. Thank you for your question. Probably as perspective for further development, probably yes. Like there are plenty neural networks like LSTM or probably some other modern models suggested, for example, like Facebook, their libraries, Prophet, or yeah, there are other also models, and generally, as I mentioned, as Prophet, yeah, it can be considered to add such models, and also like it has been mentioned in presentation, it would be really beneficial to compare these models and suggest probably the best result for users. So, yeah.
Thank you.
Thank you so much for the answers. Dear colleagues, more questions, please. If there are no more questions, let's follow our agenda. The next presentation is by Volodymyr Kisil, Peter Popov, Olga Trechuk, Valentina Hnana, and Inna Martinyuk. Concept of information technology for diagnosis and prognosis of glaucoma based on machine learning methods. Are the presenters here?
Yes, presenter is here.
Dear Volodymyr, please, the floor is yours.
Okay, so today we're going to talk about concepts of information technologies that is currently developed for prognosis of glaucoma based on machine learning, as later it will be changed to be more universal predictor of eye diseases. In this presentation, concept of diagnosis technologies is going to be described. So, understanding glaucoma. Glaucoma is a group of eye diseases characterized by progressive damage to optic nerve. It happens because of different reasons. First and foremost reason is elevated internal eye pressure. But it can also occur with normal eye pressure. Glaucomatous damage is irreversible at current technology level, so can be halted at early stages for low cost. And it is currently a leading cause of irreversible blindness worldwide after, how do I say it, not glaucoma, after normal age-induced cataract. Key points of glaucomatous disease damages are following. It's mechanical compression. It is a prolonged compression that can impair blood flow to the optic nerve, resulting in reduced blood supply and subsequent damage to the nerve fibers. Second is axonal injury. This, because of elevated pressure, mechanical stress can directly rupture nerve cells, leading to said glaucoma. Excitotoxicity. Glutamate, it is a neurotransmitter involved in signal transmission in nerve systems, plays a role in pathology creation of glaucoma. Excessive release of glutamate in response to cellular stress, or I would say normal stress to organism, can lead to this causing further damage to optic nerve cells and an increase in speed of degeneration of nerves. Neuroinflammation. It is inflammation within the optic nerve and surrounding tissues. It may happen because of previous stated glaucomatous damages. Oxidative stress. It is a result from imbalance between production of reactive oxygen and body's antioxidant defense mechanism. This is, remember, there were ads about antioxidants and etc. This is about this thing. It can, so this oxidative stress can induce said nerve damage and a normal apoptosis or programmed cell death. So this also speeds up neurodegenerations. As in short, how this can be said as having enough stress and high pressure leads to nerve degeneration that may lead to inflammation, further increased stress because of vision loss, that in turn leads to more nerve degeneration, a so-called downward spiral. It is required to prevent it in the beginnings, where it is most cost-effective. Traditional methods for diagnosing and monitoring glaucoma are mostly any other disease like it have limitations. Early stages of
Dear
glaucoma
Volodymyr,
may be...
sorry for interruption. The slides do not switch. If you
Yes, this is the second slide.
Oh, okay. Sorry then.
Early stages of glaucoma may be asymptomatic, leading to delayed diagnosis, and neural networks offer promising solutions for enhancing glaucoma detection and monitoring, which will be explained further. Importance of early detection and monitoring is standard. Prevention of vision loss. Glaucoma is often asymptomatic, and people rarely even look for it before there are symptoms, and when there are symptoms, it is often too late to prevent it. And glaucoma is irreversible, so it is better to detect it early than later. The second importance is preserving the quality of life. As said earlier, it is important to reduce the stress that can be impaired on eye and human life. Also, it increases individual's quality of life as it can impair daily activities such as driving, reading, and mobility. Early detections, as I said previously, help to preserve visual functions, allowing individuals to maintain their independence and quality of life. Problems of early detection and monitoring. Current diagnostic methods like visual field testing and optic nerve imaging have limitations. Limitations may include expensive technical equipment, for example, for fundus retinal imaging. They are fairly expensive and not very widespread. And the second problem is continuous monitoring is not frequent. And continuous monitoring of eye state of probable patients is essential for assessing disease progression and treatment efficiency. Usually, it is not as frequent because there are queues, there are often not too many fundus retinal scanners, and etc. Roles of neural networks or basic neural networks. Neural networks excel in pattern recognition tasks and can extract complex features, as you see at the right side, from imaging and clinical data. In context of artificial intelligence and machine learning, in context of artificial intelligence and machine learning, neural networks are universal functional approximators, and it is important as functions that can describe everything. Also, neural networks have such a thing that they can detect subtle changes that are not visible to the eye on different images. Next thing is that deep learning algorithm can learn from vast data sets. So, example, a doctor may learn to predict the glaucoma by viewing about thousands of different eyes and seeing about 30 of them with glaucoma, while neural networks can do that with very smaller amounts of data. Neural network, about learning mechanism. Neural networks approximate around functions that they learn. Firstly, they attempt to learn the functions. They run forward, then look at current losses, and then they run backwards to see where they should change the values. Applications of neural networks in glaucoma detection neural networks can analyze optic discs. They can also analyze coherent tomography or any type of images. They can also predict a chance of glaucoma by viewing at patient analysis or clinical data. Neural networks can analyze visual fields. Neural networks can analyze retinal data. They also automate interpretation and allow to tell patient in automatic motion what is the state with their eyes and any other and any other possible illnesses that may arise. Benefits of neural networks are following. Is accuracy, as neural networks learns at some point and it stays always at its peak. It can be further taught to see different illnesses by giving it more data. Second is efficiency and automation. For the doctor to
Volodymyr, sorry for interrupting you again. You have 2 more minutes because we need to follow the agenda.
Okay, so neural networks are more efficient than normal doctors, and neural networks provide personalized care. They do not need personalized data, only clinical data. So this solves ethical problems. Key points of neural networks information technology for diagnosis and prognosis of glaucoma are data acquisition. This is the hardest part of it. Second is feature extraction and model training. These are done locally on any computer that is capable of running such thing. And last 4 points are prognostic prediction, validation, clinical implementation, and continuous improvement. These are done after neural network is deployed and then is continually improved. Current development results. These are results from a single neural network. It was poorly trained, now it is better. These are all the results about how it can see retinal blood vessels. Conclusion and next steps. So further future directions, neural networks will hold significant part in disease diagnosis and in any other type of usage. They may allow collaboration between clinicians, researchers, and technologies, and essential for advancing the technologies and translating them into clinical practice. They also may integrate with electronic health records. Currently, we have those, but those are hard to use, as they are not numerical usually. They also solve ethical problems and they save large amount of time. They are automatic, and they may be used for any future type of development. There are also unspoken things that like money pullback for etc. that can be used to allow them to be instantialized in our clinics. This is all. Thank you for attention.
Thank you for your presentation, dear colleagues. Questions, please.
Which neural network did you choose?
I chose fully convolutional, straightforward neural network. I've seen several papers about
Thank you.
quite complex neural networks, so I used a small one.
Thank you.
I also have one question, Volodymyr. Which data set did you choose for training of your model, of your neural network?
Currently, I do not have a ready data set for glaucoma training, as it is yet in producing progress. I do have a file with set images, but they are not complete and are being completed by a local doctor. And data set that I used for retinal blood vessels detection, I used random images from internet. They have good enough quality to be trained upon.
Thank you for your answers. Dear colleagues, more questions, please?
I have one questions.
Please.
Thank you. How did you rate the quality of contour selection in images?
I used normal, how do I say, logarithmic. So
Can you see these images on the slide?
yes, this. So as far as I remember, I used logarithmic contour detection. Firstly, I drew binary detection mask that, and then used mean squared loss with logarithmic progression. So subtle small area changes are better visible.
But this contour of images have different quality.
Yes, they do. Further, it will. This is not going to be used for diagnosis. This is used to erase blood vessels. So highest quality is being learned, or how do I say? Highest quality, highest losses are being set at around optical nerve, so in center.
High quality for rich contour and more quality for small contour. Thank you.
I would say high quality for near optics disc and lower quality attention at further from it.
Thank you.
One more question from Vyacheslav Harchenko, please.
Thank you very much for your presentation. I have one question. Maybe this question is more general and concern your future research. Question is the following. When we talk about AI-based application, such as you presented, we need to formulate non-functional requirements to AI-based decision. I mean, in this case, can we formulate it's need formulate requirements, for example, to privacy, to ethics, and so on.
That neural networks do not need your personal information, only clinical data that is required. For missing clinical data, if there will be any, there will be prognostic neural networks if in the system. So example, we give scan or photo of retina, and we give some information like intraocular pressure, field of view, how do I say it? Not vision sharpness, but vision dioptrics. I don't know how to say it properly in English. I forgot the word proper.
Okay, thank you.
Thank you for the presentation, dear Volodymyr. And we go to the next presenter. The next presentation is by Serhiy Polovsyak, Olga Kreuter, Kristina Odayska, then Bali Salam, and Serhiy Stets, car image recognition using convolutional neural network with efficient net architecture. Is the presenter here?
Yes, hello. Give me one second, please. I'll share my screen.
Hello, please share your screen for us to be able to see it. Yeah, we can. Yes.
Okay. So good morning, good afternoon. My name is Serhiy Stets. I'm delighted to present our work on car image recognition using the convolutional neural networks with efficient net architecture. So we're going to discuss some motivation and the state of art. We're going to discuss the objective for our research. We're going to discuss the training data, the selection of the training data, the data augmentation steps we provided, some software implementation with efficient net architecture, how we implemented it, what improvements we gave, and what results we achieved. But before giving the technical details, let's briefly discuss the motivation behind our research and the current state of the art in an image recognition technology. So as we can see on the screen, there a graphical representation of a CNN architectural evolution over the years. There are some of the big ones like AlexNet, VGG, ResNet, DenseNet. And our motivation for undertaking this research stems from the increasing demand for the efficient and accurate image recognition system in various fields, so including like autonomous vehicles, surveillance, and traffic management. The ability to accurately detect and classify cars in the image is crucial for enhancing safety and efficiency in transportation system. And in recent years, significant advancements has been made in image recognition technology, particularly with the widespread adoption of deep learning techniques, such as also CNN. We can also see on the slide an example of a simple CNN architecture for the MNIST dataset. These models have demonstrated the remarkable performance in various image recognition tasks, surpassing traditional methods by a considerable margin. So one notable development in CNN architectures are the introduction of the efficient net. This groundbreaking architecture leverages neural network scaling principles to achieve superior performance with significantly fewer parameters, making it particularly suitable for resource-constrained applications. And our primarily objective is to develop a robust CNN model capable of accurately detecting cars in image. By leveraging the efficient net architecture, we aim to enhance the efficiency and performance of the model compared to the existing approaches. In today's rapidly evolving technological landscape, the demand for reliable and efficient image recognition system has never been higher. With the proliferation of cameras in various devices and environments, the ability to automatically detect and classify objects such as cars plays a crucial role in numerous applications, including autonomous driving, traffic monitoring, and security surveillance. So our research aims to address the challenges associated with the car image recognition by harnessing the power of deep learning and convolutional neural networks. Specifically, we seek to achieve the following objectives, which is to enhance the accuracy. So we aim to improve the accuracy of the car detection by developing a CNN model capable of accurately identifying cars under various conditions. And we can see on the slide the visual representation of the challenges associated with image recognition, such as various lighting, weather conditions, occlusions, etc. Also, we're having a very big emphasis on optimizing the efficiency. So in addition to accuracy, we prioritize optimizing the computational efficiency of our model to ensure real-time performance, particularly in application where speed is critical, such as autonomous driving systems, and also scalability. So our research also considers the scalability of the proposed approach with the goal of designing a framework that can be easily adapted and scaled to handle large-scale data sets and deployment in practical applications. So to train and evaluate our model, we selected the vehicle detection image set considering of more than 7,000 of color images. This dataset is widely available on Kaggle, and it provided a different range of images containing cars and background scenes essential for comprehensive model learning and training. So selection and appropriating dataset is a critical step in the development of any machine learning model, particularly for tasks as complex as car image recognition. This dataset, the vehicle detection image dataset, offers several advantages to our research. Firstly, its size and diversity. So with a total of 17,760 color images, the dataset provides a substantial amount of data for training and evaluation. Moreover, the images encompass a diverse range of scenarios, including different light conditions, weathers, and backgrounds and stuff we discussed on the previous slide. Secondly, its availability and accessibility. So the dataset is available on Kaggle, and it makes it easily accessible to researchers and practitioners in the field, facilitating reproducibility and comparison with existing works, which is what we're interested in. And also, the dataset's open nature encourages collaboration and innovation within the research community. We can see on the slide some of the examples of the images for cars and background images. So before training the CNN, we perform preliminary image processing, including resizing and square transformation to ensure uniformity in the dataset. Additionally, data augmentation techniques such as random rotation were applied to enrich the dataset to improve model generalization. Prior to feeding the image to the CNN model, it's crucial to preprocess them to ensure consistency and optimize model performance. So firstly, it's resizing. Images in the dataset were resized to uniform dimension to ensure that all inputs to the CNN have the same size. Resizing helps in reducing computational complexity and ensure that the model can effectively learn from all images in the dataset, regardless of the original dimensions. We can see in an example in the figure 7 when we have not a square image and we take a median color from the top half and the bottom half of the image to resize it to the same uniform dimensions to ensure that CNN have the same size. And also we did data augmentation by implementing random rotation. So images were randomly rotated, as we can see on the figure 6. They were rotated by a small angle to simulate variation in viewpoint and improve the model's robustness to objective orientation. It's also worth to note that after augmentation, the dataset is increased to about 53,000 images, which can increase the training and testing time. So our CNN model implemented using Python and Keras, it incorporates the efficient net architecture, more specifically the efficient net B0 architecture. We added layers for global average pooling and classification utilizing the softmax activation function for the final layer. The program code to implement the model based on efficient net B0 uses the Keras framework, which provides a very user-friendly interface for building and training neural network. And the first step is to load a pre-trained efficient net B0 model without the top classification layer. So the efficient net B0 architecture integrated into our CNN model offers a powerful framework for image recognition tasks and consists of multiple layers, each designed to extract and process relevant features from the input images efficiently. It is also pre-trained on the ImageNet dataset, which is very helpful in our case. There are some layers function operations. We implemented some of them within the CNN model to facilitate feature extraction, normalization, classification, and etc. You can see on the slide a fragment of the CNN model with the efficient net B0 architecture and some of the parameters of the final model. But every model needs some improvement, and to enhance our model performance, we employed various techniques like fine-tuning. So fine-tuning involves adjusting the parameters of pre-trained model to adapt it to a specific task or dataset. In our case, we fine-tuned the model with the efficient net B0 architecture to unfreeze some of its layers and training them along with the newly added layer. So the process enabled the model to learn more specific features relevant to car detection. I think we unfroze more than 20 layers. We also implemented early stopping to avoid overfitting. We implemented a learning rate schedule, which is a technique used to adjust the learning rate during training, potentially leading to faster convergence and a better model performance. And we also improve structure in addition to fine-tuning and other techniques. We made structural improvements, so we incorporated residual connections. We using leaky ReLU activation function, which allows the model to pass negative values with a small slope, improving gradient flow and preventing stalling during training, and also added additional fully connected layers with dropout. These layers helps to regularize the model and prevent overfitting by moderating model complexity and controlling the propagation of the gradients. After the training, the CNN model for about 10 epochs, we achieved an accuracy of the basic CNN model of 82%, which, while demonstrating the model's capability, this accuracy prompted us to further refine our approach for better results. And initially, the training phase of our CNN model provided valuable insights into its performance and potential areas for improvements. The key results are that after building and compiling the basic CNN model, it was trained and it took about 25 minutes, which achieved not the greatest accuracy. Our improved CNN model exhibited remarkable progress, reaching an accuracy of approximately 99.7% on the validation dataset with a significantly reduced training time and improved accuracy. our model demonstrates the effectiveness of the efficient net architecture in car image recognition. So analyzing the results, the improved CNN model leveraging the efficient net B0 architecture with some improvements demonstrated a remarkable increase in accuracy with our model surpass expectation and achieve exceptional performance in car image recognition tasks. It also improved upon the already existing solutions, which can be presented with the same Kaggle dataset. In conclusion, our research showcased the efficiency of convolutional neural networks with efficient net architecture in car image recognition by leveraging advanced techniques in data processing, augmentation, and model optimization. We achieved exceptional accuracy and efficiency in detecting cars within images. So the key takeaways would be the effectiveness of CNN with efficient net, the significance of advanced techniques, and the successful approach we took. What are the practical applications? So the implication of the research extends beyond academia with practical application in various domains, such as automotive industry. So our CNN model can be utilized for car detection and recognition system in autonomous vehicles, enhancing their ability to perceive and navigate the surrounding environments accurately and, most importantly, safely. Also surveillance and security. The developed model can be deployed in surveillance system for a real-time monitoring of traffic flow, parking enforcement, and most notably vehicle tracking. Some smart cities ideas. In the context of smart cities, our model can facilitate traffic management, congestion detection, and urban planning. Our future direction with our research is extension to multiple class recognition, expanding the scope of our model to recognize not only cars, but other types of vehicles and objects, enabling comprehensive scene understanding and analysis. Also incorporating contextual information such as road conditions, weather, and traffic signals into the recognition progress, enhancing the model adaptability and robustness in diverse environments. Also maybe implementing sliding window approach, and we will obviously continue with optimization and refinement to optimize our model through ongoing experimentation and research to further improve its accuracy, its efficiency, and applicability across various use cases and scenarios. So that's it for me. Thank you.
Thank you so much for your presentation. Dear colleagues, any questions to the presenter?
Some question. Why did you choose efficient net?
So there are a couple of ways to think about it. The most notably is that it's a state-of-the-art performance while being computationally effectiveness. So we can scale it pretty easily. It is very efficient. We thought about using something like ResNet or VGGNet or DenseNet, but some of them have their unique advantages and disadvantages. In terms of performance, we would like to have an efficient neural network because we would like to have a real-life feed, for example, using something like FFmpeg to recognize images on the video on the live feed. This means that we would want a neural net to be efficient and fast, and also to achieve a high accuracy. So something like efficient net seems like a reasonable choice for this task. So hope that answered it.
Thank you so much for your presentation, dear Sergey. And we go to the next presenter. The next presentation is by Olga Pavlova, Ivan Rudek, and Huda El-Bouhisi, post-processing of video surveillance systems, alarm signals using the YOLO V8 neural network. The presenter is Ivan Rudek. The floor is yours.
Okay, thank you. Dear participants, today we are honored to share insights into our study post-processing of video surveillance system alarm signals using the YOLO V8 neural network. Companies that specialize in providing of comprehensive video surveillance services often face the problem of pattern recognition quality. We know one such company which operators daily receive signals about violations from more than 400 cameras. The average daily number of signals is almost 3,000. That means more than 80,000 for an average month. It should be noted that the majority of cameras are located outside and are significantly affected by various factors that cause false alarms. These factors can be divided into some categories like precipitation, wind, light effects, and all the mentioned factors, and more often their combinations, make up a significant part of all camera activations. So for an average month, the number of false alarms consists more than 51% of all alarm signals. Considering that each alarm must be verified by a person, false alarms cause significant losses to the owner, forcing to keep an increased number of operators on the job. These images show examples of errors in pattern recognition on images from outdoor surveillance cameras. At picture A, you can see false recognition of a refrigerator and a truck at the place of cargo containers. At page B, people at the place of pile of tires. At page C, false identification of a truck and a person at the place of the cargo container at demarcation column. And finally, at image D, a false recognition of trucks in the place of minibuses and a person in the place of a limiting partition. So since external surveillance cameras are intended mainly for enterprises security purposes, the problem of high-quality recognition of patterns on the video from the cameras is quite important for the automation of operators' work. The search of a solution has been ongoing for almost 10 years. The number of cameras is increasing. The latest streaming videos analysis systems are being put into operation. However, the quality of automated image recognition that could satisfy the company's security parameters and eliminate the human operator from the process of monitoring the cameras, or at least decrease his involvement, this was not achieved. In the course of the study, scientific publications devoted to the application of model based on artificial neural networks were reviewed. 3 of these neural networks, like Google Cloud Vision API, PyTorch, FasterEye, CNN, and YOLO V8, were chosen for testing. It was decided to collect a dataset of 20 test images and conduct a comparative analysis on the quality of pattern recognition. As you can see, dataset contains also images in infrared light in shades of gray, on which there are images of various objects on a construction site, cars, people. As you can see, there were not privative images. And as you can see from the table below, the result of the analysis showed that the YOLO V8 model coped best with the pattern recognition on the test dataset, so it was decided to build further work on its basis. Considering all the risk of implementation of new image recognition system instead of existing, it was decided to build for now this new system as post-processing. At first stage, we tried for object detections the ready-made model presented by YOLO V8 developer Ultralytics company. Model was pre-trained by developer on COCO dataset. Version extra large of the model was used as the most precise. Clips were forwarded to the post-processing at the moments when there are supposed to be no people at the moment. But as you can see, neural network found people there. Since the main purpose of the video surveillance conducted by the client company is the protection of objects, at this stage it was decided to verify additionally the results where people were detected, I mean person class. Verification was carried out by human operators. The results of video verification at example of 4,800 images are shown here at diagram. Only 0.7% of the total number of clips has been identified by the program as person, were confirmed by the operators. That is, the error of the second kind was more than 99%. Then we considered 3 kinds of factors that potentially can influence at this result. Errors of human operators who made verification, errors in the pattern program that used YOLO network, and errors in the object detections by the YOLO neural network. We have focused on the work of improvement of object detection by selected neural network. It was decided to train the network model from the scratch using data from real video cameras of the client. This job started from dataset preparation. To say briefly, at this stage, it was necessary to find images that contain type of objects that we need, person in our case. The images preferably should be received from the same set of the cameras where the object detection will be occur then. The next part of this work is labeling. This part requires the most time. For each image received, there should be created a description where each object of interest, person in our case, is situated. This description is saved within special labeling file in TXT format. Each image in dataset should correspond to each own labeling file. For the training dataset 4,900 images containing 6,100 objects of the person class were obtained. The number of background images which did not contain any objects is 92. The number of prepared images for verification is 300. Training was carried out in Google Colab. Data was downloaded from Google Drive. 120 learning epochs were launched. Training was started with empty weights for YOLO 8S model. Index S means small size of the model. GPU Tesla V100 was used. Each cycle tested about 2 minutes. Considering that the version from the box was trained on images of 640 pixels width and the size of the videos for the client cameras usually are bigger, up to full HD, it was made decision to use a size of 1280 pixels width in the training parameters to provide better detailing during further object detection. Evaluation of training results was carried out in 2 ways, using the obtained metrics and manually. We are saving data from the video using the newly created model and manual searching for the erroneous results. Besides the set of charts out of the box, YOLO V8 API provides the default option of saving a wide range of metrics through the epochs in CSV file. We use part of this data for the experiment result estimation. As for the obtained metrics, they indicate, on the one hand, the success of training. There is an improvement in the values of the parameters train box loss and mean average precision, with an increase in epochs. Let me show you again. On the other hand, the relatively stable value of validation box loss starting from epoch 84 suggests natural performance fluctuations due to too small size of validation sample, only 6% of the training sample. Manual verification revealed a decrease in the proportion of objects and identified with errors by the newly created model to 10.7% compared to 19.4% for the out-of-the-box model. As a conclusion, we can consider our work as quite successful. We can see prospects for the improvements, and we know how to achieve this. Thank you for your attention. Please feel free for your questions.
Thank you so much, dear Ivan, for your presentation. Dear colleagues, any questions?
Why did you use the YOLO neural network?
As I mentioned in my presentation, it demonstrated one of the best results. And compared with other networks that reached the same result with object detection, YOLO V8 has a much more friendly API. That's why we decided to use it.
Thank you.
More questions, please.
Yes, I have a question.
Please.
Dear Ivan, have you evaluated the quality of your data set? Markup quality, data balance, data representative set?
Actually, no, we didn't do this. If you if you can give us more details why by your opinion we had to do this. We will consider this in our further research because we're planning to continue with our researches.
Thank you.
Thank you so much. We will discuss it at the coffee break. Thank you so much, dear Ivan, for your presentation. And we move forward to our last presentation of this section by Tatiana Говорущенко, Oleg Wojcir, Olga Говорущенko, Artem Boyarchuk, and Irina Zasornova. The concept of information technology for ensuring accessibility to art objects for the visually impaired person. Is the presenter here?
Yeah, yes.
Dear Ivan, could you
Ivan,
please
please,
stop screen sharing for the next presenter to be able to share the screen? Oleg,
Yes. See my
we can,
sharing
yeah,
screen?
we can see your screen.
Okay, our work is a concept of information technology for ensuring accessibility to art objects for the visual impaired person. So, first part of this presentation talk Olga Vorushenko, please.
Yes, of course. Introduction. We will start with basic. Vision is one of the most important human senses, as the visual analyzer provides more than 90% of information sent to the brain from all receptors. Vision is a multi-chain process that begins with the protection of an image on the retina, followed by the excitation of photoreceptors, the transmission and transformation of visual information in the neural layers of the visual system and visual perceptions, and by the decision of the higher cortical areas of the visual system about visual images. It's not uncommon for people to lose all or part of their vision. Blindness or serious visual impairment can be caused by various factors. This include injuries and diseases that damage the eyes, optic nerves, or brain. The next. For many centuries, the idea of a blind person as an inferior personality has been formed in everyday continuous. A blind person was seen completely different person, and the possibilities for the development of such a person, his or her participation in cultural life, were considered extremely limited. Therefore, the current challenge is to ensure accessibility to art objects for the visually impairment person by development information technology that provides converting 2D images into 3D models and generation descriptions for them in Braille. As a STEAM project for solving the real-world problems that requires the integration of cross-disciplinary knowledge and connections. The next. Neurophysiology of sensory process. The main functions of sensory systems are signal reception, conversion of receptor signals, and contact receptors into impulsive activity of nerve pathways, transmission of nerve activity to sensory nuclei, conversion of nerve activity in sensory nuclei at each level, analysis of signal properties, identification of signal properties, classification and recognition of signals. The better the sensory system works, the more accurate the information the brain receives. Imagination is a mental process that consists in creating new images by processing the materials of perceptions and ideas gained in previous experience. The emergence of images is the result of the activity of the human brain, namely the cerebral cortex. The complexity of the structure of imagination and its connection with emotions suggests the physiological mechanisms of imagination are located not only in the cortex but also in deeper parts of the brain. Such part of the brain is hypothalamic limbic system. The hypothalamic in its connections with the ancient cortex and subcortical areas that create a limb around the front of the brain stem at the entrance to the cerebral hemispheres. Next. Sight people have more neurons in the cerebral cortex area responsible for processing visual signals than in the areas of hearing and touch. This is why sighted people analyze their environment primarily with their eyes. As a person loses their vision, the visual cortex no longer receives incoming signals. Long-term experience for perceiving the world without the use of vision, affecting the morphological structure of certain parts of the brain, leads to a restructuring and the entire system to receiving information through the preserved analyzers. Such changes occur in the course of life. In the process of development, blind people develop new ways of perceiving and analyzing reality, orientation in space, which plays a leading role in their cognitive activity. If the loss of vision occurred in adulthood, the person thinks in the same way as sighted people, but receives information about them through other senses. If a person lost their sight in childhood after the age of 5, then their visual memory is poorly developed, and their perception is based mainly on hearing and touch. In people who lost their sight in early childhood, the visual information processing center in the brain begins to process auditory, verbal, or tactile signals. In people who have been blind since birth, the area of the brain responsible for converting visual information into images does not work at all. The next. Tomograms of blind participants showed the obvious difference from those of the participants with normal vision. Blind people has increased connections between some parts of the brain. Significant changes were found not only in the occipital cortex, which is responsible for vision, but also in the areas responsible for memory, language, and sensory motor functions. Different parts of our brain can reorganize to compensate for different sensory areas. The brain of a blind person can reprogram areas normally responsible for vision to improve, for example, auditory or tactile sensitivity. Visual areas in the brains of blind people are comparable in size to those of healthy people, but not visual areas are larger than normal. If the brain does not receive information from any sense organ, it can recognize itself to enhance the functions of other senses as evidenced by a lot of evidence. Even in the case of complete blindness, the brain reshapes itself to make the best use of the information and its disposal and interact more effectively with the external environment. So the potential of adaptation of a blind person is quite large. This phenomenon is called compensation. Compensation is restoration of underdeveloped or impaired mental functions by using the preserved or restructuring partially impaired functions from a physiological point of view. The basis of the compensatory process is the mobilization of significant resource capabilities of higher nervous activity. In blind people, the most function of the visual analyzer is compensated for by the active activity of preserved analysis, auditory, motor, tactile, etc. Touch is great importance in the perception and cognition of reality for visually impaired people. Tactile perception provides a complex of various sensations and helps to determine the shape, size, and figure and establish proportional relationships. As a result, blind people can perfectly develop the tactile perception of special features and special relations, which allows them to use a kind of tactile IGOG for approximate estimates of size and dimensions. The next. When touching, a person can perceive an object only in separate parts due to the fact that touch perception is carried out at a lower speed compared to the visual perception. The tactile image of an object is formed more slowly, so large size of an object that is studied but touched by visual impairment person will be significant obstacle for blind people. Touch is extremely important because it's directly involved in the reflection of objects and phenomena of the environment, physical and mechanical properties of the surrounding space. For blind people, touch is the main way of object cognition of the environment. So the brain of the blind person is able to convert tactile information into visual images. So tactile paintings created using 3D modeling and 3D printing technologies will allow blind people to see artistic masterpiece with their fingerprints. Oleg, welcome. Continue.
Okay. Yes, thank you. So this part is it's a technical part, and now I can show you methods who we look to create our work. So first method what we look is devoted to evaluation of image quality with the purpose of finding the higher performance method for evaluation of stereoscopic image quality. In the study, two convolutional neural network-based methods for evaluation of stereoscopic image quality, which considering semantic features of stereoscopic image. Next method, we know the study is investigated to the potential biometric recognition in 3D imaging in medicine. Authors consider various 3D imaging techniques in medicine and their advantage and disadvantage. Magnetic resonance imaging, MRI, 3D ultrasound imaging, 3D near infrared imaging, computer tomography scans. Next method is proposed the method involves extracting image face information using 2D Gabor filters and applying it to dense optical flow estimation based on polynomial approximation and semi-global block matching for obtaining robust 3D image measurements. And last method propose the method for rendering to the image of 3D face meshes directly controlled by a single to the reference image using again this disentanglement. This method involved an input of a 3D mesh and a reference image, where encoded extract geometric features for the mesh and apprehends features from the reference image. So the concept of information technology for ensuring accessibility to art object for the visual impaired person. Our technology have like this principle of design and operation of such information technology are first the principle of development and phasing, the possibility of updating and expanding the functional of information technology without disrupting its previous functional. Second, the principle of efficiency, achieving maximum effect while minimizing the cost of information technology. Three, the principle of automation of information flow processing. Automation at all stages of create information flow from primary information to obtain an information product. The principle of adaptivity, operational restructuring of information technology if necessary to solve new problems. The principle of openness of information, ensuring the accuracy, truthfulness, and reliability of information. The principle of compatibility, the availability of a communication mechanism for the interaction of information technology with users and with other technology and system. And the principle of legality complements with the current laws in Ukraine. So let's look our scheme. Let's develop a context diagram null of the functionality model of information technology for ensuring accessibility to art object for the visual impaired person. So
yeah,
first,
sorry for interruption. You have 2 more minutes because
okay. Let's look our results. So how we do our work. So first we give to the image. Download its IE slice this image to 2 different image. First image it's a figure 6. Sorry. It's create a normal mappa. It's show where are image high, low, and more. And figure 8 it's the grayscale mappa. It slice our image to more deep groove. And figure 10, it's a final result of what we send to 3D printer and create a barrelief like this. So maybe you have some questions.
Dear colleagues, feel free to ask your questions to the presenters. Okay, I have one. Dear authors, what are the further directions of your research? What is going to be the implementation of this?
Now we're trying to create some prototype this work. I have someone I can demonstrate it. I hope it's you can see this. So it's girl with jewelry and but so like this. So
Yeah, we
this
can
is
see it.
barrelief.
Thank you.
We have a deep grave, and blind people can touch it and find detail in our work. But it's a method like start, and we have some problem. We have must to solve it. Yes.
Thank you so much. Dear colleagues, more questions?
May I also ask a question?
Yes, please.
Okay, thank you very much for your presentation and for your research. And I'd like to point out that it's really urgent in terms of our inclusive society in general, and in terms of so-called universal design, the concept which is getting more and more popular nowadays. And my question is, how are you going to test your prototype? How are you going to find out the key I don't know, target audience? And are you going to do it exactly with people who have these problems or some disorders? How are you going to do it? Can you say in a few words? Thank you.
Thank you for question. Now we have a plan to connect with the blind society in our town, and now we printing more prototype, different quality, and go to meeting, and they test this prototype, and what is prototype best touching and best send information to blind people. We continue to evolution this prototype.
Thank you for your answer, and I wish you success in your following up research. Thank you.
Thank you so much for the presentation and for the answers. Dear colleagues, now we have a little coffee break, and at 2 p.m. we are looking forward to seeing you at the next section. Thank you so much. Take care.
Thank you. It was very great to see everybody, and a great honor to be a part of your community. Thank you for the invitation to the workshop. Thank you. See you. Bye-bye.
Thank you so much for warm words.